All right, so my iPad decided my video had been long enough, so it cut me off right in the middle of that. So what we did is we reduced our ratio, and these are considered to be the same ratio, okay? So one's reduced, but for every 5 beans, we've got 1 black-eyed pea, 2 black and 2 red, and that's the same as saying for every 10 beans, we're gonna have 2 black-eyed peas, 4 black and 4 red. All right, so that takes us through ratio. The next thing we wanna talk about is a rate. So a rate is a type of ratio. So it is a ratio that compares two quantities with different units. So the key here is different units. Okay, so for example, maybe I give you 60 miles was traveled using 3 gallons of gas. So we've got miles and gallons, so we've got 2 different units there. Now when you see something like this, a lot of people are really tempted to reduce this and say, well, that would be the same as 20 miles in 1 gallon. And so this is what we call a unit rate, and this is definitely the most common type of rate that we see because it's really the most useful. So a unit rate is a rate with 1 in the denominator. Okay, so we could take our rate from up here, and if we went ahead and simplified that, we would have 20 miles for every 1 gallon. Things like this are really common in the grocery store. If you want to compare things that are different sizes, so like when my kids were little, I would look at buying diapers, and all the different brands had a different number of diaper in their packages, so it was really hard to compare. But what they would do is they would write the unit price. So maybe you would see something like 27 cents for every 1 diaper. And so even if your packages are different sizes, you can compare and see which one is the better deal. So unit rates are really handy for that. All right, so if you would look now at the back of your handout, we have here a proportion. So this is kind of our next topic after ratio. So a proportion is just a statement that 2 ratios are equal. Okay, so I'm going to steal our example from the previous page. I had 60 miles for every 3 gallons, and we claimed that that was the same as 20 miles for every 1 gallon. So that brings us to the next question. How do we know if a proportion is true? Well, one way we can do is we can check cross products. So one thing is that cross products must be equal. Okay, so by cross products, let me grab a pen here. I'm looking across this way, and I want to multiply those together. So that would be 60 times 1, and I want that to be equal to this cross product, which will be 3 times 20. And I can check that and see that they are equal, so I know that that proportion is true. Another thing I can do is I can get a common denominator and compare. Okay, so if you get the same denominator, as long as the numerator is the same, then you know that they match up. Another thing you can do is reduce and compare. This doesn't always work because they don't always reduce to be the same thing, but that we could in this case. We could reduce the fraction on the left to be the fraction on the right, and we'd know those are the same thing. Now the last one I'm going to mention is one that we're really going to focus on in this class, and this is find a multiplier. So if you're teaching younger kids, maybe you're teaching 2nd or 3rd grade, but you're trying to prepare some proportional reasoning skills. They don't have the algebra skills to set up an equation and cross multiply. So we're going to talk a lot more about this on Wednesday, but what we do is we look for what's called a multiplier. So I'm going to take this example and write it down again. So what I do for a multiplier is I compare my smaller number to my bigger number. So I'm comparing my numerators, and I'm thinking from 20 to 60, I need to multiply by 3. So if this is a proportion, if it's a true proportion, I should have the same multiplier on the bottom. So if I go from here to here and multiply by 3, I can see that 1 times 3 gives me 3. So this is what I mean by multiplier, and this enables younger kids to do some proportion problems, assuming that these multipliers are nice numbers. All right, so the last thing we're going to talk about, we're really going to try to answer this on Wednesday. What makes a relationship a proportion? So what I'm going to do is I'm going to show you 2 examples. One is going to be a proportion and one is not. So the first one I'm going to show you is a proportion. And this is just to get us thinking about these relationships. So for this one, I'm going to say if I can travel 90 miles in 2 hours, then I should travel blank miles in 3 hours. Now there's definitely some assumptions made in this problem. We're assuming an average or constant rate of speed. So we are assuming a constant rate of speed. Now that right there is a dead giveaway for proportion, this idea of a constant rate. That's saying that anything I pick and make into a rate, they should be equal. So there's a couple of ways we could solve this. We could set up a proportion, we could cross multiply. We could sort of logically figure this out. We could say, okay, if we're doing 90 miles in 2 hours, maybe you go down to a unit rate and you say, well, that would be 45 miles in 1 hour. So you're basically reducing it, even though you're not writing it as a fraction. So that would make sense. So then if I wanted to figure out 3 hours, I could just triple both of these. So there's that multiplier of 3. And that would give me a total of 135 miles in 3 hours. So that would answer my question for sure. So this is not the only way you could do it, right? You could certainly set up a proportion. But this idea of a constant rate of speed, that's a proportion. So let's look at one that's not a proportion. So for this example, I'm going to give you a comparison between my son and I. So I'm going to give the statement, when I was 40, my son was 10. So I kind of stole this from our old textbook that we don't use anymore. What the old textbook asked us to do, which I thought was kind of interesting, it asked us to do an additive comparison and a multiplicative comparison. I'm going to abbreviate that one. So for an additive comparison, I'm thinking, what do I need to add to 10 to get 40? Right, so for an additive comparison, I would say I am 30 years older than my son. All right, so that would be an additive comparison. For a multiplicative comparison, I'm thinking, what do I need to multiply by 10 to get 40? So that would be 4. So I would say here, I am 4 times older than my son. So we still haven't really hit on the idea of, is it proportion or is it not proportion? So to determine that, I would need more than one data set. Okay, so on this problem, I kind of gave you 2 things. I gave you the 2 hours and I gave you the 3 hours. So here I gave you one data set. So let's bump it up about 20 years and say, when I am 60, which is thankfully a long ways from now, my son will be 30. All right, so if I look at this data set, let's think about the additive comparison. So what do I need to add to 30 to get 60? Well, it would be the same as the one up here. I would still be 30 years older than my son. So I'm just going to write same. But if we look at the multiplicative comparison, it's going to be different. So now if I look at what to multiply to 30 to get 60, it would be 2. So I will be 2 times older than my son. So if I'm trying to really define the relationship between me and my son, so what I'd like to do is maybe write an equation or get a graph or something like that, notice that these changed. So the relationship between my son and I is not a multiplicative relationship. This statement is always going to be true. I was 30 years old when he was born, and assuming our birthdays are the same, which close enough, I'm always going to be 30 years older than him. So this is where the relationship is. So it's not a multiplicative, it's an additive relationship. And if I wanted to even define that as an equation, I could say y equals x plus 30, where x would be my son's age and y would be my age. All right, so if I plug my son's age in and add 30, I should get my age. And that's going to be true all the time. So what that means is this relationship is additive, not multiplicative. This is going to be really important for next time, because we're going to see that when we're talking about proportion, proportion is always a multiplicative relationship. It's very, very tied to multiplication. So since this is additive, it is a relationship, but this relationship is not a proportion. All right, so once you finish these notes, to get your 100 for the day, I want you to take a picture of both sides and email it to me, and then that's how you will get your 100 for today.